All right, we're going to review for our test today. I'm going to do this one. I'm going to go through them relatively fast. Then you guys will ask questions afterwards. When you want to expand something like this, you got to use the binomial theorem. It's written on your reference sheet. We learned it in class. See how it starts at 4 down over here? Yeah? So you take the first number. You're going to have to go 4C0, right? You remember this? X to the, what's the first one start at? First one starts at 4, and the other one goes down. It starts at 0, and then that one goes down. And then it goes 4C1, x to the third, negative y to the first, 4C2, x squared, negative y squared, all the way down to the bottom. So there you go. That's what you do. Then we simply need to plug that into the calculator, find out how much each one of those combinations is, fill it out, write it all down. So there you go. If you plug them all in and multiply them out, you get that. When you simplify it out, you get that. And finally, when you write it out, fully expand it out, you get this. Look at that. Look at that. I made a mistake. Yeah. This should have been an x squared. This should have been an x squared. Is that the only mistake that I made? And on the bottom over here, that should have been an x squared. Yeah. So it should go 4, 3, 1, 2, 2, 1, 3, 4. Yeah, that's right. Good. Thanks. Same kind of question. I'm just asking for a random term, right? Which one do I want? Third term? Some people get confused about how to find the term. So just write it out real fast. Right starts at 6. That means 6C0 would be the first term. 6C1 would be the second term. 6C2 would be the third term. That's the one that you want. You know what I mean? If it's 6C2, then the rest of it has got to be x, right? What are the numbers going to be? Is it confusing? Yeah, it's x4. Well, let's just see. Let's do it really easily. The first term in the sequence, x would have started at 6, and then this would have been negative 2y to the 0. The second term would have been x to the 5th, negative 2y to the 1st. So this would have been x to the 4th, negative 2y squared. See how to do it now? Real easily. Doesn't take too long. You don't even need to count on your hands if you don't really like that. Let's plug it into our calculators, find out the answers. We're going to do 6 math probability, NCR. 6C2, so that's 15. The rest of it I can do in my head. So this is going to be 15 times x to the 4th times 4y squared. 60. That one. How many ways can 4 vehicles park in 7 available spots? Does order matter? Think about it. Think about it. You and 4 friends, right? Come along. There's 7 spots. Each time you park, does that produce a new parking sequence? Dude, order mattered. It mattered how you pulled in. If you were last in line, you'd be further away from school. How many ways can 4 vehicles park in 7 available spots? It's tricky, but it happens to be, I'm sorry, it's not a C, it's a P. 7P4. That's it. What's up? Seven P4 840. What's the answer, he said? Yeah, there's no way. $840. That's it. Guys, remember the word problems? Okay. Yeah. How many different number of unique arrangements can be made from the letters in Elizabeth? How many letters we got there? Okay. So there's definitely 9 factorial ways that that can be done. There are 2 E's. 2E. Is that it? Is that all the repeats that there are? So that's it. Everybody know how to punch that into your calculators, though. All right. 9, math. Scroll to factorial, probability, go to factorial. 9 factorial divided by 2 factorial. 18, 14, 40. That's it. Okay. Jacob's registering for a website. He's got to select a password beginning with 1 letter, followed by 5 digits from 1 to 9. How many passwords are possible if no digits may be used more than once? Right? How many choices do you have for a letter? Yeah, there's 26 letters in our alphabet. So you had 26 to choose from. This is like a pants, shirts, socks type problem. What are you going to end up doing to all these numbers? Multiplying them out. How many choices did you have for that first number? Regardless of what it is, how many are there 1 through 9? Dude. 9. You had 9 choices. You had 9 choices. 1 gets taken. How many choices do you have for the second number? 8. Sorry, I said letter, right? Yeah. And then 7, 6, 5. Just multiply them all out. That's how it works. $26 times 7 times 8 times 7 times 6 times 5. 39, 39, 31, 20. Guys, we're playing football. 31 players on the team. How many different 11-man lineups can be formed if playing position doesn't matter? Is this combination, permutation? It's a combination. It's like choosing lab groups, right? Order doesn't matter. We're not even going to assign positions. 11 people are just going to come out and play football. If order doesn't matter, it's going to be 31C11. You know, you can't do it the opposite way. Because this number in the front over here tells you how many items you have to choose from, and this tells you how many you want. So if you only have 11, if you suppose you switch it, what you're saying is how many different ways can you choose 31 items from 11? None. There isn't enough to fill all the spots. 31 math. Whoa. 84, 67, 23, 15. 84. Let's just make sure it's right. 84, 67, 23, 15. Yeah, that's right. That is a lot of ways to play football. Ah, probability, my favorite. The probability of rolling exactly 3 4s in 5 rolls of a fair dice. 3 4s in 5 rolls of a fair dice. So every time you do this, I've taught you to do N. What do we do? Yeah, NRPQ every time. N, 5 rolls. Exactly 3 4s. The probability of rolling a 4 on 1 dice is 1/6, and the probability of failing at that is 5/6. So it's just 5C3, 1/6. How many 4s do we want? 3. And then just punch that into your calculator and find it out. Right? parenthesis 5 math whoops, sorry about that, 1/6 to the third, 5/6 squared. We get a random number like that. Just convert it to a fraction. Math. 125 over 388. We also don't see that, right? You know, it's got to be one of the fractions that's up there that has not been reduced. Well, that's annoying. So now I'm just going to go looking for this decimal. Which one do you think it is? 125? If I had to bet, I think it's the first one. Because 125 doubled is 250, and I have to bet 380 is 250 divided by 6. Is it A? Yeah, it's A. Look at that. Let's play again. These are once again an exactly problem. The probability that it will rain on any given day this week is 60%. That's looking about right compared to our weather outside, you know. Find the probability it will rain exactly 3 out of 7 days. So, you know, N, R, P, and Q, 7, 3, 0.6. That means this is 0.4. And we're just going to do 7C3, 0.6 to the third, 0.4 to the fourth. Plug it into our calculator, find the answer. Okay. So we punched it in. That's our probability. You could leave that as a decimal if you want to. You could convert it to a fraction if you feel you like that better, but both are completely fine. 1935, 36. 1935, 36. Guys, you're looking at that decimal. Tell me, what percentage is that? Yeah, basically, there's like a 20% chance it's going to rain 3 out of 7, exactly 3 out of 7 days. Okay, so let's do this one. A soft drink company is having a contest by printing a prize on the reverse side of some of their bottle caps. The chances of winning any prize are 1 in 4. Howie buys 10 drinks. What's the probability to the nearest tenth that he's going to win at least 3 of the prizes? So the best thing you can do is fill this out. N, R, P, and Q. How many drinks is this man buying? 10. And now here's the tricky part. He's going to win at least 3 prizes. So that's 3. R stands for the number of things that you want, whether it's raining 3 days or winning 3 prizes. You know what I mean? R is typically found after the word at least, at most, or exactly. It's just with at least and at most, you have to know which way you're counting the R, whether it's downwards or upwards. What's the probability of winning? 1 in 4. What is that as a decimal to make it nice and easy? 0.25, and that means I got a 0.75 chance of losing. Now, this is a tricky one, right? We learned 2 ways to do it. You literally could do the exactly formula 1, 2, 3, 4, 5, 6, 7, 8 times. Or you could do it for 0, 1, and 2 and subtract that away from 100%. Do you know what I mean? Okay. So, which way do you want to do it? The shorter way? Okay. Let me show you the shorter way. The real short way is to subtract away, is to do 1 minus, right? You know what? I'm going to need way more room. The short way about doing this is to do 1 minus, and in parentheses, we are going to do, let's see, 10C0, 0.25 to the 0, 0.75 to the 10th, plus 10C1, 0.25 to the first, 0.75 to the ninth plus 10c2 0.25 squared 0.75 to the eighth. So here's what you're doing, right? You're basically subtracting away everything that would count as a failure. And if you do that, you by default get everything that was successful for the scenario. So I'm subtracting away losing 10 times, winning once and losing 9 times, winning twice, losing 8 times, because the problem asks that he needs to win at least 3. It's an easier way of attacking it, but if you don't like this, instead of doing this 1 minus what fails, you could just as easily take the long route, make it nice and simple, and literally find the probability of exactly for each one of these scenarios and simply add them together. It's just going to take more time. Do you understand? Okay. So now we're going to plug this into our calculator and find the answer. So there you go. Is that the right answer from the back? Yeah? So what does it want? To the nearest tenth. To the nearest tenth of a percent. Where is that? Let's write down the whole thing so people don't get confused about rounding. 47, 44. What else is the rest? 47, 44, 07, 196. Okay, let's go back up to the big screen. Right? If you convert this to a percent, it's going to be 47.4407196%. And then how much is that to the nearest tenth? 47.4. And that's your final answer. So Tim Parker, a star baseball player, hits 1 home run for every 10 times he's at bat. Parker goes to bat 5 times. This is going to be an N, R, P, or Q question. Parker goes to bat 5 times during the night. What's the probability he will hit at least 4 home runs? So that means he's got to hit a home run 4 times. He's got to hit a home run 5 times. So what's the probability he hits 1 home run for every 10 times he is at bat? Does he suck? Yeah. It's a 1 out of 10 chance. That means he doesn't hit a home run 9 out of 10 times. That's horrible. What is this? What's 1/10 as a fraction, as a decimal? 0.1. It's like 10 cents. So here we go. We are going to do 5C4, 0.1 to the fourth, 0.9 to the first, plus 5C5, 0.1 to the fifth, 0.9 to the 0. And what do we get? Okay, so you punch this into your calculator, you get 0.00046. So we had a question about, right, how to convert this. Yeah, e to the negative fourth means you move it over 4 spots. That's what that means. So let's talk, find the range, find the interquartile range. This is a statistics question. You enter it into your calculator. Let me just go dual screen so I can use my calculator at the same time. Stat, edit, enter the price in 1, 1.8, 1.82, 1.84, 1.86, 1.88, 1.96. Then we got 4, 2, 2, 2, 3, 3. Now you see how it's asking for the range and the interquartile range? The range, right? These numbers or these ideas are found from doing stat, calc, one variable statistics, L1, comma, L2. Prints me up all this data. You know what I mean? I mean, you really should. The range is the max minus the min. The interquartile range is Q3 minus Q1. It's very simple, very, very simple, right? You're going to have to remember that, but that's not that hard. Max 1.96, min 1.8, so that's 1.96 minus 1.8. I think that's what? 0.16. That's the range. Q3 minus Q1. Q3 is 1.88. Q1 is 1.81. So this is 1.88 minus 1.81. How much is that? 0.07. That's what we do.